So in our second electromagnetic radiation video, we're going to look at LADs, and I'm not talking about the inappropriate Facebook channel. I'm talking about laser airborne depth sounding. So let's get into it. So LADs was a technique that was pioneered by South Australian scientists, which is why we like to inflict it on South Australian physics students. And basically it gives a way to much more safely and much more quickly map the ocean floor, and in particular to look for underwater reefs and other underwater hazards. I know there's a spot out behind, sort of on the shipping entrance to Port Lincoln, they call Laser Shoal, which is actually a potential shipping hazard that no one had ever detected before and was picked up by one of these LADs planes. So what basically is involved is an aeroplane flies along and it shoots down a red laser and a green laser, and these actually flies at quite low altitude, and these scan a small region of the ocean floor. And what it does is it measures the time. Basically it sends two pulses, a green and a red pulse simultaneously, and then it times how long each takes to come back and be detected by the plane, and it works out the difference between those two times. So the light travels at the same speed in the air, so the difference between these two times indicates the time, if you like, from when the laser penetrated the surface of the ocean, went to the ocean floor, then reflected back to the surface. So this time here indicates, if you like, that time for the laser to go down and reflect back up. So then, if we know the speed of light in water, or the speed of electromagnetic radiation, in this case green laser light, in water, we can basically distance equals speed times time. So depth equals the speed of light in water times by the time. We've got to divide by 2 though, because the light goes down and then comes back up. So that's, if you like, the process is used to work out the depth of the water, and that's happening on a continual basis. Couple of points about this. The green laser is used to monitor the ocean floor rather than the red one, as the red light doesn't penetrate the ocean well. That's actually why a lot of deep ocean or deep sea fish are red in colour. It's because red is very hard to detect at great depth. But that's getting into biology, and this is physics, and we don't really want to talk about biology. We also need to justify why we need to use really powerful lasers here to do this. That basically is laser light is scattered by sediment particles in the ocean. So there's all sand and mud and even little fish and plankton and all sorts of things in the water, and they will scatter off some of this light, so it won't have a chance to get reflected back to the plane. Laser light is also absorbed by the water molecules. As the laser hits the water, it makes the oxygen and hydrogen bonds in water vibrate, taking away some of that energy. And finally, the ocean floor is not a very good mirror, so we get poor reflection, or it's a poor reflector, so most of the light isn't reflected back up to the plane, but we call it diffuse reflectance. It goes off in all sorts of directions. So they're the 3 reasons that we need to use powerful lasers. Hopefully that all makes sense. I haven't done a example problem here. I reckon you'll do a couple in the book, and I think based on this approach here, you should be able to work that out fairly well. Obviously, if you have any problems, sing out, and I'm happy to go through one. Cheers.